this is a differentiation question in which I have y equal x cubic minus 40x plus 1. You need to find the x coordinates, for which the gradient is 8. So I find the differentiation, the y dash. So it's going to be the power times the x, then the power minus 1. So it's becoming 2. So it's 3x squared. Same goes here. It's going to be 1, x power 1. Then the power is multiplied by negative 40. So it's going to be the same. And then 1 minus 1 equal to 0. So x power 0 equal to 1. So it's going to be negative 40 times 1, which is basically negative 40. So just to save your time, if you saw a number, then like a number, and beside it the x to the power of a positive 1, so you just write it without the x, omit or remove the x. Then you allow the y dash to be equal to 8, then you move the 40 by the plus, it's going to be 48, then divide by 3, it's going to be 16, 16 equal x squared, so x is plus or minus because both points, so I have 2 points and you need plus or minus in square root or in even root, like square or 4 or 6 or whatever. So it's going to be root 16, so it's going to be plus or minus 4. So x is plus or minus 4. To find the coordinates, you need to replace in the original equation to find the y. So when x equal to 4, so the y equal to 4 cubic, in brackets, don't forget the brackets, negative 40 times 4 plus 1, so in the calculator it's going to be negative 95, so it's going to be 4 negative 95, and then when x equal to negative 4, so it's going to be y equal to negative 4 in brackets. Let me show you. If it's negative 4 to the power of 3, it's negative 64. Yes, in this case, it doesn't matter. However, better to put it in brackets, especially if the coefficient is in negative, just in case, like in square, this matters. So just do it always. It's going to be 155. Oh no, it's 64. So that's going to be 97. So negative 497. So I have either 4 negative 95 or negative 497. You find the equation. To find the m, you get y2 minus y1 over x2 minus x1. To get the m, then the c is the intersection with the y-axis, which is basically the 1, intersection of the line. Line intersects at this point. The m, I can take this point and this point, for example, or this point. Better to make them further. So it's going to be like this, rise over run. I can make it rise over run. 1, 2, 3, 3 over 1, 2, 3, 4, 5, 6. 3 over negative 6, which is negative half. You can make it either rise over run or better to make it with steps. Better, because sometimes they're marked. Gradient, when it's perpendicular to b, to the line perpendicular to b, you find the m by isolating 5y, or sorry, making y a subject. So it's going to be 5y equal 7 minus 2x, then the y equal to 7 over 5 minus 2 over 5x. Negative 2 over 5x, or negative 2 over 5 is the m of p. M of the line perpendicular is going to be 5 over 2. Because it's negative 2 over 5, or negative 1 divide and negative 2 over 5. And here A, B, C, D is a square. Square. No, I need a square. Okay. And better to write it clockwise, the numbers in this direction. Then A is negative 5 over negative 5, 2, and B is 3 and 5. Find equation and that pass through B and C. It's just basically this one. I need to find the equation for this equation. Okay, so basically find the gradient of AB, m of AB by y2 minus y1 over x2 minus x1, 5 minus 2 over 3 plus 5. This is 5 minus 2, 3 plus, yes. So it's going to be 3 over 8, the m of AB. So the m of BC is going to be 8 over negative 8 over 3. This is done by negative 1 divide the gradient of the perpendicular line. You're going to get this same answer. So then you substitute, you write that 5 minus, y minus 5 equal x minus 3 equal to negative 8 over 3, then cross multiplication, so you'll get 3y minus 15 equal to negative 8x plus 24. Then you put them all on one side. Coordinates will L and C intersect. You solve them simultaneously, basically. Curve has a minimum point, tangent to the curve in the minimum point, so you find G and point. How to draw a line, equation of a line. We always know that line equal a point, that you need point and a gradient. I'm moving just fast in some questions because they're easy, and I'm stopping only for the harder questions. Okay, so to find the gradient, I know that the gradient will equal to 0 because minimum point, any minimum maximum point in a curve is going to be, or in any graph actually, is going to be equal to 0. So y dash equal to 8x to the power 3 minus 64. I told you that if the number it's going to be like a coefficient beside x to the power of positive 1, it's going to be written without the x simply, but in any number where x is to the power of a positive integer, so it's going to be multiply the power to the coefficient, then the power minus 1. So I know that y dash is equal to 0. So 0 equal 8x cubic minus 64. So 64 equal 8x cubic. So x cubic equal to 8. I have only one choice here because it's x cubic, no plus or minus, because plus or minus is only for roots or even like 2, 4, 6, and so on. But for odd, if it's positive, so the final answer is going to be positive only. Because of that, you're going, it's easy because you would choose 1 point. So this is the x. I need to find the coordinate, the point, the rest of the point. So I'm going to substitute the value of x in the original equation, not the gradient, because even if I tried substituting gradient using the value of x, I'm going to get it as 0. So I'm just repeating the whole steps and wasting my time. And you won't get the true value of y. So you substitute 2 or substitute x in the original to find any coordinates. So it's going to be y equal to, oopsies, 2 times 2 to the power of 4 minus 64 times 2. So 2 times 60 minus 64 times 2 is going to be negative 96. So the point is basically 2 and negative 96. And gradient, or m, is equal to 0. So x, y minus negative 96, which is going to be positive 96, and then x minus 2 is equal to 0. So it is going to equal to y plus 96, 0, equals 0. This is the equation. So curve C has an equation y equal x squared minus 8x minus 9. Straight line has a equation y equal k is an integer. So C and L intersect at point A and B. So I have curve C and line L. They intersect at 2 points A and B. A is P and K. B is Q and K. Given that P minus Q is equal to 14. By logic, if I have a number like x minus y equal a positive number, so x must be greater than y, right? Keep this idea in your mind. Find the value of x. So first, I have to substitute with the value of y equal k. I must use this and substitute in this equation. So it's going to be k equal to x squared minus 8x minus 9. I have right now an integer, an unknown with x. No worries, don't panic. Just add it to the other side with the other terms, and then use this formula to make x as power of 2 a subject. It's going to be p squared over 2a plus or minus, it's going to be p whole squared, and negative. Then negative p over 2a squared minus c over a. And here, it doesn't specify. Either I'm going to use positive, which is greater than, or negative, which is smaller than. Because of that, I have two values. So x will equal to b. I must keep in mind that this is a, this is b, and this is as a whole is c. So negative 8, which is positive 8, over 2 times 1, a is going to equal squared, it's going to be squared plus or minus 8 over 2 times 1 squared minus negative 9 minus k. I must put the brackets because the negative is going to be distributed over both, as if it's negative 1, and then over a, which is 1. So it's going to be 8 over 2, which is 4, to the power of 2, which is 16, plus or minus, all this is x, and then it's going to be also 16 minus, or plus 9 plus k. So it's equal to 16 plus or minus, plus or minus 16 16 plus 9, which is 25 plus k. This is x, so this is the x. So p and q. So I have one is p, one of the solutions, because I have two solutions. I have plus alone and negative alone. One is p and one is q. And I told you that p is greater than q because their difference produces a positive number. So p, as is the greater, so it's going to be 16 plus, because I add 16. When I add 16, the number is greater than when I subtract 16, right? So it's going to be 16 plus root 25 plus k. Then q is going to be 16 minus root 25 plus k. Basically, they're identical. However, the signs here are different. So using this, I'm going to solve it. And in this case, the only unknown is going to be k, and it's going to be easy to solve. It's going to be 16 plus 25 plus k under the root minus brackets, open brackets, because the minus sign is going to be distributed over the numbers or terms in the brackets. 16 minus root 25 plus k, so it's equal to 14. 16 plus 25, oopsies, 25 plus k minus 16 plus root 25 plus k is equal to 14. Mm, 16 and negative 16 will cancel, then it's going to be 25 plus k under root plus the same identical one. Imagine it as if it's root x plus root x. What is it going to be? It's going to be 2 root x. The same here. It's going to be 2 root 25 plus k. Treat it as root x equal 14. So 25 plus k under the root is going to be 14 over 2, which is 7, because I moved the 2 by division, inverse operation. Then you, to remove the square root, you put it on squared. It's going to be 25 plus k equal to 49. K is 49 minus 25, which is equal to 24. So k is equal to 24. This idea we solved it millions of times. Perpendicular straight line. L is perpendicular to a straight line with the equation following. It passes through the point this. So you find the equation of L. You find the m here, then negative 1 divided by the m you find is going to be the m of L. And you do what we did before.